Assalamualaikum warahmatullahi wabarakatuh. Welcome back to our channel. Now let's learn about Doppler Effect. The Doppler effect is observed whenever the source of waves is moving with respect to an observer. The Doppler effect is the apparent change in frequency of a wave caused by the relative motion between the wave source and the observer. When an object approaches the observer, the wavelength compress causes the frequency to increase. This phenomenon is known as blue shifting. And when the object moves away, the wavelength spreads, causing a decrease in the frequency value. This phenomenon is known as red shifting. Some example of Doppler effect around us: car horn, the sound of the helicopter engine approaching, the sound of the train approaching, and the sound of the train starting to move away. The formula of Doppler's effect. The formula of Doppler effect is F accent equal to V plus minus VO per V plus minus Vs times F, whereas F accent is observed frequency, the unit is Hertz. F is actual frequency, the unit is Hertz. V is velocity of sound waves, the unit is meter per second. VO is velocity of observer, the unit is meter per second. And Vs is velocity of source, the unit is meter per second. Because the formula of Doppler effect have plus and minus, so you must know when you can use the positive and negative. This is the positive and negative rules. And this is the formula of Doppler effect. To use positive sign if the listener approaches the source, it means VO is positive. And the second, source away from listener, it means Vs is positive. And when use negative sign if first, listeners stay away from sources, it means VO is negative. And the second, the source approaches the listener, it means Vs is negative.
Doppler effect. They are the source and the observer. If the source toward to the observer and the observer toward to the source, so the frequency of the observer more than frequency of the source. But if the source move away from the observer and the observer move away from the source, so the frequency of the observer less than frequency of the source. Question number 1. An ambulance truck emits sound with a frequency of 600 Hz. A. What is the frequency detected by a stationary observer if the ambulance truck is moving 40 meters per second toward to the observer? B. What frequency will be detected if the ambulance is moving 40 meters per second away from the observer? The speed of the sound in air at 20 degrees Celsius is 340 meters per second. To count the frequency of the observer, we can use this formula. V is velocity. The sign positive if the observer toward to the source and the source move away from the observer. The sign negative if the observer move away from the source and the source toward to the observer. 4.A. If there is source is moving 40 meters per second toward the observer, so velocity of the observer is 0. To count the frequency of the observer, we can use this formula. We can input the value of the velocity of sound in air is 340 and input the velocity of the source. Why the value is negative? Because the source toward to the observer. So the velocity of frequency of the observer is 680 Hz. For point B, there is a source is moving away from the observer. The velocity is 40 meters per second. For count the frequency of observer, we can use the same formula. The velocity of the source have positive value. Why? Because the source is moving away from the observer. So the velocity have positive value and the frequency of the observer is 5308.84 Hz. Question number 2. A stationary ambulance truck emits a frequency of 1200 Hz. Calculate the frequency detected by the observer if A. The observer is driving toward the ambulance truck at 30 meters per second and B. The observer is driving away from the ambulance truck at 30 meters per second. The speed of sound in air at 20 degrees is 340 meters per second. We use the same formula and the same statement for the sign. Let's do point A. There is the source, stationary source, so the velocity of the source is 0. and the observer is driving toward to the source with velocity 30 meter per second. We use the same formula to count the frequency of the observer. The frequency of the observer, we can input the value of the velocity of sound in air. Why the velocity of observer have positive value? Because the observer toward to the source. So the frequency of the observer is 1305.88 Hz. For point B, there is the stationary source, the velocity is 0, and the observer is driving away from the source with the velocity is 30 meter per second. So the value of the observer is negative value because move away from the source. So the velocity of the observer is 1094.12 Hz. Question number 3. A police car is moving east at 60 meter per second toward a driver who is moving west at 70 meter per second. The police car emits a frequency of 800 Hz. What a frequency is detected by the driver if the speed of sound in air at 20 degrees is 340 meter per second. This is the same formula to count the frequency of the observer. Still same statement as before. Let's recount. There is the source is moving east at 60 meter per second and a driver is moving also in west direction at 70 meter per second. We use the same formula to count the frequency of the observer. We can input the velocity of sound in air. Why the velocity of the observer is positive value? Because the observer toward to the source and the velocity of the source is move away from the observer. So the frequency of the observer is 1185.90 Hz. Okay, that's all about Doppler effect. I hope the material is useful for you all, and thank you for watching.